Okay, so good morning to everyone. So in the last class we have discussed about the IPv4 and the IPv4. So in the IPv4 we have discussed about the class full address, and today we will discuss about that how we find the class of an address. So in IPv4, how we find the class of an address we will discuss today. So we have already seen that there are total three notations present in the IPv4, that is the binary notation, dotted decimal notation, and hexadecimal notation. So mainly in between these three, the two are the maximum use, that is the binary notation, and another is the dotted decimal notation. Now, we have already 5 classes present, that are class A, class B, class C, class D, and class E. Now, in case of binary notation, to find the class of an address, we have to check the first byte. Now, the total address length, the length of the address in IPv4 is the 32-bit. Now, 32-bit means what? 32-bit means if we convert it to the byte, that means 8-bit, that is 1 byte. So that means 32 bits means 4 byte. So 4 byte. In this 4 byte, the first byte, seeing the first byte, we will specify that in which class the address is present. Through seeing the first byte, we will see that in which class the address is present. Now, in case of binary notation, in case of first, we will see the binary notation. Then in case of dotted decimal notation, we will see. Now we will check the first byte. Now for class A, if the first byte is 0, then it will be in the class A. If the address looks like 10, then it will be in the class B. Now if the address looks like 110, then it will be in the class C. If the address is 1110, then it will be class D. And if the first address will be 1111 like this, then it will be of class E. And in case of dotted decimal notation, the range is specified. So if the first byte is between 0 to 127, then it is of class A. Then 128 to 191, it is of class B. 192 to 223, it is of class C. And 224 to 239, it is of class D. And 240 to 255, if the first byte range is between 240 to 255, then it is of class E. So now basically, like this, questions will be given that find the class of each address. Now the first example which I am showing, in this example, this example is given in the, you see, the values are written. So that means this example is given in the dotted decimal notation. According to the dotted decimal notation, this example is given. So we have to check what? We have to check the first byte. So here the value is given 227.12.14.87. Now, if we see the range, 227, that means we have to check the first byte. The first byte is 227. Now, 227 is in the range of, is the 227 is in the range of class D. If we see, class D's range is 224 to 239. And here the value is 227. So that means this is in the range of class D. Then 193. So 193 will be what? 192 to 223. The range from 192 to 223, it will be of class C. So we like this, the first byte, according to the first byte we check, and according to the first byte, we will put the values. Now, if in the exam, if you have given that each address, binary notation address, according to the binary notation, the address is given. This address is given according to the dotted decimal notation. But if the address is given like this in the binary notation, in case of binary notation, the address is given. So we have to check the binary notation first byte binary notations table, which I have mentioned. So in here also you see first byte it is given 000000001. So that means first starting with 0. If it is starting with 0, that means if it is starting with here 0, that means it is of class A. If it is starting with 110, if it is starting with 110 like this, then it will be of class C according to the table. According to the table, if we see that if it is starting with 110, that means it is of class C. The next we will look, the next value is 101, 101000111. So 10 means it is of class 10 means it is of class B, and then 1111 like this. So if this like this, then that means it is of class E. So according, you have to remember the table in the binary notation. In case of binary notation, what will be the first byte, and in case of dotted decimal notation also, for the first byte we have to check the first byte to know in which class this address is present. In case of binary notation, the values we have seen that for 0 it is of class A, 10 for class B, for class C it is 110, for class D it is 1110, for class E it is 1111, like this. And for class dotted decimal notation, some ranges is given. So according to these ranges, you will see the first byte, and according to the range you see, you will put the class, in which class the address is present, you will able to put that. So this is what, how to find the each class each address to find out. So in exam you may be given, that using the dotted decimal notation or the binary notation, in any form the address will be given. So according to it, you will check the first byte, and in the first byte you will remember the table. This, according to the table, you will put the values. So this is the basic to find out the each class address, in which class this address is present. This is the basics. We move the net ID and host ID concept. Now it is going to clear that what till now in the Cisco packet tracer, that how we choose the IP addresses, all I have shown, that now it will be much clear to you that how we put the values, how we put that in the discussing of the Cisco packet tracer. In that time, I am saying that we are taking class C address, class B address. So according to this table, we are putting the values, and we are saying that in this class it is present, in this class this address is present. So according to the table, we are telling that. Now we will move to the concept of the net ID and host ID. Now we have 5 classes present: class A, class B, class C, class D, class E. These 5 classes are present, but in between these 5 class, only 3 classes, we are dividing it into net ID and host ID. A, B, and C, these 3 classes, over these 3 classes, we divide it into the net ID and host ID. And class D and class E, we do not divide it into the host ID and net ID. Only class A, class B, and class C, we divide it into according to the net ID and host ID. So here you see we have prepared a table. And in this table there is byte 1, byte 2, byte 3, and byte 4. Because why we write that? Because IPv4 is the 32-bit. 32-bit means what? 32-bit means 4 bytes. So 4 bytes, we divided these 4 bytes like this: byte 1, byte 2, byte 3, and byte 4. Now for class A, if the address that is present, if the address is present in class A, then its first byte will be the net ID, and remaining 3 bytes will be the host ID. First byte will be the net ID, and remaining bytes will be the host ID. So let's say like this example, let's say this is an address given 14.23.120 and dot 8. So this 14, now this 14 is what? In 0 to 127 range. So 0 to 127 range is what? That means it is of class A. So that means this will be the net ID. This will be the net ID. And this 23.12.8, this total 23.12.8, this will be the, this 3 bytes will be the host ID. This 3 bytes will be the host ID. So this is what for class A, the byte 1 is of net ID and other 3, byte 2, byte 3 and byte 4 are the host ID. For class B, byte 1 and byte 2, these two are the net ID and byte 3 and byte 4 are the host ID. And for class C, the first three bytes will be the net ID and the last byte will be the host ID. So this is where, this is the net ID and host ID we divide in the class. For class A, byte 1 is net ID and other 3 are the host ID. For class B, first 2s are net ID and byte 3 and byte 4 are the host ID. For class C, first 3 are the net ID and the last one is the host ID. Okay, so this is the table. This is the table of the net ID and host ID, and according to it, it is prepared. Now we'll move to the concept that is mask. Now, what is the mask? Mask is used to help to find the net ID and host ID. Mask is used to find the net ID and host ID. And mask is a 32-bit number. Mainly mask is a 32-bit number and it has number of ones contiguous, which is followed by number of zeros, which are also contiguous. Now mask is basically used to find the net ID and host ID. And mask is a 32-bit number. Mainly mask is a 32-bit number because IPv4 address is the 32-bit. So mask is also the 32-bit number. And in this mask, we have contiguous one, that means continuous one. That one, after completing that one, it will be followed by zeros. Contiguous, that means constantly. So first one, then after completing one, it will be zeros contiguously. So this is the main concept of the mask. Now, when I am assigning the IP address, if you remember in the Cisco packet tracer, when I am assigning that IP addresses, in that time, when I am assigning the IP address, if you remember that I am writing, when I am taking the class C IP address, when I am taking the class C IP address, I am writing 255.255, then 255, then 0. Like this, we are subnet mask, we are writing that. So through this, if in this concept we will able to define that subnet mask we will able to define. Now if you see, our total bit is what? Our total bit is 32 bits. Our total bit is 32 bits. So that means first n bits will be 1 and 32 minus, because here it is said it is a number of ones contiguous, which is followed by the number of zeros, which are also contiguous. Means first ones will be there and then after following one, there zeros will be present. So our total is 32 bit. Our total is 32 bits. Now, first n bits will be 1 and 32 minus n bits will be 0. Means first n bits we will use 1 and after 32 minus n, that number of bits, we will use zeros here. So now how we will find n? What is the value of n? Now for class A, so for class A, n value will be 8. For class A, n value will be 8. Now how we find that the n value is 8? You may ask that how I find that n value is 8. Now this n is based on the net ID. Now for class A byte 1 is the net ID. For class A, byte 1 is the net ID. So byte 1 means what? First byte will be the net ID. Now one byte means what? One byte means 8 bits. One byte means 8 bits. So that's why class A, if we consider class A, the first byte is net ID. So first byte net ID, that means what? First 8 bits will be the net ID. So instead of n, it will write here 8 bits 1, 8 bits 1, and 32 minus n, that means 32 minus n, it will be 24. So 24 bits 0. So the binary mask we will write here. You see, first 8 bits 1. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 ones. Now this 8 ones will be followed by 24 zeros. So that's why I will not write fully, but this is the 24 zeros followed by this one. And now if we convert this into the binary, if we convert this binary into the decimal, that means this 8 bits we will take, this 8 bits, then another 8 bits. So like this we will take. So if we convert this 8 bits, we will find 255.0.0.0. So these values we are putting in that time. In class B, in case of class B, 2 bytes. In case of class B, 2 bytes are the net ID. 2 bytes are the net ID means 16 bits are the net ID. 16 bits are the net ID means instead of 8 bits, it will be 16 bits. It will be 16 bits. So 16 bits 1. So 16 bits 1 followed by 16 bits, because 32 minus 16, it will be 16. So 16 bits zeros. It will be 16 bits zeros. So that means what? 16 bit 1. So that you see, first I have written 16 bits ones, and then the 16 bits 1 are followed by 16 bits zeros. Now we are grouping it as the 8 bits. So we are grouping because 1 byte equal to 8 bits. So we are grouping it as the 8 bits. So if we group this, it will be 255. Then another, it will be 255.0.0. So that's how we are getting the decimal values. Now you are considering, now it becomes clear to you that why I am writing in that time 255.255.255.0. Like this we are writing. For class C, in case of class C, first 3 bytes are the net ID. So that means 24 bits. 3 bytes means what? 24 bits. So 24 bits will be the net ID. 24 bits will be the net ID. That means 24 bits will be, first 24 bits will be 1. And 32 minus 24, that means 8 bits. So first 24 bits will be 1, followed by 8 bits will be zeros. Now, if we consider this, then first 8 bits, then again 8 bits, then again 8 bits, like this 24 bits. So this will be ones. So that means if we convert this into the decimal values, this will be 255, this will be 255, like this. That's why I have written 255.255.255.0. Okay, so this is the thing. This is the thing. In that time, I am writing in the subnetting mask. In the mask, I am writing 255.255.255.0. Now, in this way, we are finding the values of the mask. Okay, clear? It is clear to everyone? It is clear?
Yes, sir.
Okay. So this is the mask. So using this mask, we will find the net ID and the host ID. So finding this, we use the net ID and host ID. Now you can say that why I didn't use the class D and class E address. Now for class D and class E address, we do not use generally, because class D address is used for the multicast purpose. Basically, class D address is basically used for multicast purpose, and class E address and the class E address which is used, that is class E address are reserved for the future purpose. For the future purpose, class E address is reserved. So that's why we do not generally use this. We generally use these three classes: class address, that is class A, class B, and class C. And class D and class E. Class D is used for the multicast purpose, and class E used for the our uh, reserve purpose. Our reserve purpose, we have reserved these addresses for future use, or some scientifically doing some scientifically research, we can use it. So basically, generally, we use this three types of or three class of IP address: A, B, and C. Okay, so this is all about our class full addressing. But there is also a concept that is the classless addressing. Now, why this classless addressing came? We will say that why this classless addressing came in the picture. Because now initially initially the IPv4 address is divided into the 5 classes. So 5 classes we have seen. That is in the mid-range of 1990s like this. But later on, we have converted it into the classless address. It is converted into the classless address. Now, in this classless address, it is the variable length blocks. In classless address, the variable length block are used. Variable length means the length are not fixed. Variable length blocks we used, and that belongs to no class. That means class concept has gone. So that means no class A, class B, or class C, or class D. No such concepts are able there. Now, for classless addressing, there are some restrictions also present. Some restrictions we have to keep in mind for the if we use the classless addressing. Now, what are the restrictions? Now, addresses in a block must be contiguous. That means one after another. In the block, the addresses is present. That will be one by one. Means the value will be one by one. And the number of addresses in the block must be the power of 2. So the number of address in a block, there will be the number of address present. And in this block, the address that is present will be one by one. And also the number of address that is present on that block will be the power of 2. So that means power of 2 means it will be 1, 2, 4, 8, 16, 32 like this, because power of 2. So this is the second restriction. And the third restriction is the first address must be evenly divisible by the number of address. That means the first address that is present will be evenly divisible by the number of address. Through the number of address, we evenly divide this, able to divide the first address. So let's take an example. Through an example, we can understand. So let's say there is a block present. Let's say there is a block present, and in this block, the addresses are present. So 205.16.37.32. Now do not mismatch it because it is the classless address. So classless address means 205, that for checking the first byte, it is not needed because it is classless address. That means no class is associated with it. So here, normally an address is given. Let's say normally address is given. And in this block, what I have said, in the block, number of addresses can be present. But the addresses can be one after one. That means addresses will be the contiguous. So let's say the first address that is present in the block is 205.16.37.32. This is the first address. So that means it will be contiguous. So the next address will be 205.16.37.33. Then after that, the next address will be 205.16.37.34. Then like this, let's say like this 34, 35, 36, 37, 38, because one after one another. And the last address, let's say the last address is 205.16.37.47. So here you see the first condition, it is satisfying because all the address are contiguous because it is coming one after another. Now next is the number of addresses on the block must be the power of 2. So from 32, if we consider starting from 32 to 47, so that means total address present in this block is 32. So that means 16. So number of addresses present is 16. So the 16 means what? It is the power of 2. So this restrictions is also applicable. And the third restriction, that the first address must be evenly divisible by the number of address. For doing this, you have to convert this into the binary form, and after this you will divide. If you see, then it is evenly divisible. So these are the restrictions. These are the restrictions that is present in the, these are the restrictions that is present in our classless address. For classless addressing, these restrictions are present. So same as that for classful addressing also, we have the mask concept. Same as that for classless addressing also, there is the mask concept. Now, mask concept is what, for what why we use the mask concept. It is the better way to define the block of address. It is a better way to define the block of address. And the marks value is what, 32-bit. That means it can take from 0 to 32. The same thing which we have done for finding the mask in classful addressing. Here also we will do that. That leftmost n bits, the leftmost n bits that is used will be 1, and the rightmost, that means 32 minus n, the remaining bits. After the n bits, the remaining bits, because our total bit is 32 bit, IPv4 address is 32 bits. That means first n bit, if we consider the first n bit, it will be the first n bits will be 1, and the rightmost 32 minus n bits will be 0. But the difference is, it is here defined using the slash notation. Here it is defined by the slash notation, or also called the CIDR notation. Using this, it is defined here. So let's say this, like this example, this general format, this is the general format. It is shown that like this, the address is given x.y.z.t/n. Now, this n is the mask. So for classless addressing, to rewrite the classless addressing, it is like that it defines the mask. It defines this n like this. This is the general format. This is the general format, and this n defines the mask. Now we will see how to extract the information from the classless addressing. From the classless addressing, how we will extract the information? We'll see that. Now there are the important points which you should have to remember to extract the information from classless addressing. That is, first, First address in the block can be found by setting the rightmost 32 minus n bits to zeros. The first address that is present in the block can be found by setting the rightmost 32 minus n bits to zeros. These points you should have to remember, because if you didn't remember these points, then you cannot able to extract information from the classless addressing. Now, next important point is that the last address can be found by setting the rightmost 32 minus n bits to ones. And the total number of address that will be 2 to the power 32 minus n. This number of address can be present. So let's discuss this with an example. Let's say like a problem that is given that one of the address is 205.16.37.39/28. Now find the first, last, and the total number of address. So like this, a problem is given. Now, if you remember the general format, the general format here, x.y.z.t/n. So according to this general format, if we compare, then n is what? N is the 28. According to the general format, if we compare, and n is the mask, this define the mask. So here we have written that n equal to 28. Now to find this, the easiest way is to convert this number into binary form. Don't consider the mask. Only the values, this values. So what we have done, we converted this into binary form. So 205, the binary form will look like this. This 16, the binary form will be look like this. For 37, the binary form will look like this. And this is the binary form of 39. Now you see, we didn't consider the 28 because we didn't consider the mask. Now what is said, for finding the first address, we have to convert the rightmost 32 minus n bits to zeros. Now n is what? 28. So 32 minus 28, 4 bits, because 32 minus 20, that is 4. So that means rightmost 4 bits will be converted to zeros. So here you see this 4 bits, rightmost 4 bits, we converted it into zeros. These ones are converted into zeros. So rightmost 4 bits, are converted into zeros. So using this, we will find the first address. So after the other bits will be remaining same. It will be remain same. We didn't change that. Only the last 4 bits. Why? Because 32 minus n value is 28, marks value is 28. So rightmost 4 bits will be changed to zeros. So the rightmost 4 bits we have changed, and it converted into the zeros. And after that, if we again convert it into the decimal form, then it will be look like 205.16.37, and here it will be 32. Same as that for case of last address also. For last address, we have to do what? For last address, we have to convert the rightmost 32 minus n bits to ones. That means 32 minus 28, that will be 4. So the rightmost 4 bits in case of last address, rightmost 4 bits will be converted into 1. So rightmost 4 bits will be converted into 1 here. So you see the rightmost bits here, 32 4 bits are converted into 1, rightmost 4 bits. Now if we again converted it into the decimal form, then it will looks like that 205.16.37.47, because if we convert it, then it will be 47. So in the block that is mentioned in that block, the first address is this and the last address is this. We already found it. Now, how many addresses are present in the block? So for finding that, what we have to do? We have to do 2 to the power 32 minus n. 2 to the power 32 minus n. So 32 minus n is 28. So that means 2 to the power 4. 4 means what? 2 to the power 4 means 16 address. So total 16 address is present there. Now if we calculate, that is 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. You see, both are matching. That means what? The 16 addresses is present, and the 16 addresses are contiguous. So like this is a one way to find the first address, first address in the block, last address in the block, and the total number of address that is present in the block. This is a way. Okay, till now it is clear.
Yes, sir.
Okay. Now there is also another way present. Another way is here the number of address format is same. In this, the number of will be n will be number of address will be 2 to the power 32 minus n. In this case, for finding the first address, we will do what? We will address and mask, means mask value. With this mask value, we'll perform the AND operation. And for last address, for case of last address, we will do what? We will do address. First, we'll write the address, then we will do the OR operation with the complement of the mask. Sorry, we will complement of the mask. So we are taking the same example. Let's say we are taking the same example. That means for the same example, if we see the value is 205.16, 205.16.37.39. Okay, so it is 205, then 16, 16.39.37. Sorry, 37.39. 37.39. Now, if we convert this into the binary form, it will looks like this. It will looks like the address will be looks like this. Now, for finding the first address, what we have to do? For finding the first address, we have to perform AND operation with the mask. Now mask is 28. Now the mask is